we continue on chapter 4. In the chapter 4.3, talking about the magic method within Python. This is kind of interesting topic here. First, let's look at the mind map. Within the mind map in 4.3, you can read from the book, but just for convenience of you learn the complete set of the knowledge, I put some key information here. First is it is called 魔法方法. In English, is magic method, or we also can call that as the dunder, the method. In Python, the method has two prefix and the suffix underscore. So you put the two underscore before and the two underscore after. Then that is the magic method definition. So, and I put our link here, the notes here. Dunder means double under. So dunder is short for the double under underscore. Use dir int to list the magic the function in Python. So let's try to, if you go to our command, you put a Python, you put dir int, then here is all the magic method within your Python version. In the different version, it can be slightly different, but majority are same. Okay, so that. It's Control-Z. Then I quit this. And the general method for the magic. Here I put some more, the complete list. So if you can read from the free plan here, then you can get this. I also group this by the different the category. So first is the initialization and the construction. The magic method is including three, like underscore underscore new, and then the initialization. So this we already learned before, and also del. So that is the some description. Magic method is just some method that it can be running or executed based on certain condition. So for this new magic method, it will get code in an object when it's an instantiation. So when you create our new instance of the class, then this new magic method will be running. Similarly, is the initialization is get called by the new. So when new finished, then new method will call initialization method. And when it is this object is being distracted, then this del magic method will be automatically running. So there is three magic methods called the initialization or constructing form the object's life cycle. So they also call this object life cycle methods. And then similarly is we have some magic method for numeric, for arithmetic, string. So those are certain the kind of the familiar things that we have done. So learned during the data structure. So if you have a trunk, seal, floor, when this behavior is implemented, then this magic method is called. So you can put some code within such kind of magic method, then that will be triggered by the some mass method, the standard mass method. And then there's a big list for this arithmetic, but no vary. Those are just the familiar items in the different operator. So, and for the string, also a list, and we will mention this str during our later examples. It will be defined behavior for when string str method is called on an instance of your class. So in Chinese, is when you print an object, it will be automatically running this str, and the argument is a self. And there's some others magic method talking about the string. And also we have the comparison. So for this logical operator, so you have this equal, not equal, less than, greater than, less than, and equal, greater than, and equal. So those 6 one. And the last is this iteration magic method. We will also mention this when you traverse the list of the object, this iter magic method will be running. When this generate data and return, the next magic method will be running. And then this way, based on those magic methods, we will introduce the iterable the object. So if our class implement this iteration iter magic method, then this class is our iterable the object, and iterator is called if they implement iter and next both, then it's an iterator. So within Python, list and dict are iterable object, but not the iterator. So it's not so easy to grasp this. Let's do sample to this. So let's come to 4.3, and we go to our book. So 4.3. You can read of those things, but now I hope you already know whenever you see 2_ before and after, this is our magic method. The author gave you some the basic ones, and we are talking about the first sample about this this new initial and delete to see, and we use this sample. So let's create our part is magic lifecycle.py. So within this one is first, let's see, we create our class, define a class, and within this class you see here, first 3, the function are all magic method, and the last one is say, so it's just our normal the method. So we will define this one, and from outside we will instantiate it of this class, and then we will use our instance to call this non-magic method. So that is the logic for that. So let's first make my class. So I keep that empty first, then this I make this initial. So and then when I have such one, so you see here, expect an indent block. So because here I have this one, so you remember here I say if you don't want to put anything inside your class, you cannot leave it empty. You need to have a path. Then here the structure of your code is okay. Then we can start to build one by one. So we built our basic the magic method first. So we say self, then print auto calling say. And then with this one, then we can see c.c. So you can see is correctly coded, but then is what we are going to do is define this 3 lifecycle based magic method one by one. So first we make our new, because this is the first. So new, you need to give our some argument. It's just a class, and with this star argues. That means it's the variable numbers, any number of the those positional based argument and the keywords based arguments. So you have these two, and within this you can see print execute till new. So if this is running, then they will tell us this one is code and the return. So this one, the author I think is gave you some something. So new is if you use new, you must return one the object call the parent class instance. So that is just the Python have such kind of the rules. So super is the parent class, then dot new and same with these arguments. So we can see here is execute till new, then go to the say. So when this class is created or initial the instance, then when we create our instance of my class, this say new is running first before any other the method. So we can put this as new, and then we define our IIT. So does also have self, and then print execute till IIT. So we can code this. After new running is the new magic method call IIT, then is coming to say. So even let's just make our test. If I put say first, let's see, it's not changing your result because say must be running after you have this instance and initialize that. And then this even I put the DL before. So that's let's see, define DL self, print execute till DL. So let's run this. The DL will be the last. So this called the life cycle. So you can create more method for your class, but these three. First is new, second is INIT, the last is DL, and you have your the class between the DL because say new. So let's say I have our new. So I want to call say new. Oh, I need to save. You can see here, first new initial and then say new. DL always be the last. So that is the thing. So I have one more, the underscore. So that gave you mislead. So that is the showing the life cycle. So I hope this one you get 431 the understanding. Then we can come to this iterable the object. So we use another one to make our sample. So let's create our new one. Give a name. Oh, this one. Oh, I should create here. So if I give a name, oh, where is my file? Oh, here. iterable object ty. So let's analyze this object. It's from collection ABC. So we have we need to load this iterable method. So these are in the collections package. So with the ABC import. Notice here the I started is the capital, and then we define our class myList. So this one same as we starting from the initial IIT. Argument is only self and the self dot list equal list. That is our initial the function. Then we define the use this iter, also only say self and nothing we need to put here. Then we have this one add data. Self data is 2 arguments, comma data. Then if is instance. So what that means, if these are instance, we compare is whether this instance is a string. The instance use this input data with a string and the data not in self list. Then we will do self list, add one new record, which is data, and we put this an indent in an indent. Last one is use the string. So we can see here. So what I gave you is in the string is here. So many. So you can see here the string. It gives you the defined behavior for when str is called. So that is the string, the magic method. Self. Let's do let is return string self with this list. So now we have our class defined. Well, we initial instance my class myList equal to myList. So that is use this one, and we have our iterable. We will use that import this iterable use. So then let's see myList dot add data Python. Let's here print myList. Nothing. So we keep having this after every argument, the statement. So myList add data. So we add a data because it's empty. We can just call because its instance is string. Data is a string, and the data is not in the self list. So this means it's not exist for now. Then we will have this self list append. And then same is myList add data. Now this time is 1. So let's see. We didn't add 1 because 1 is not a string. And then myList add data. Oh, fine. twice. Then print. So we should add the second one. Then let's try to add the Python again. You can see here, we will not make Python again. So just this non-repeatable the element is instance my list. Use this iterabel is instance as. So is true. So my list is iterable because we use this iter to make this define. So this iter, what was this running? So when we use this one, so when we explore the traverse of object, this method will be automatically executed. So that make your this list or object being the iterable the object. So because this one is linked to this one. So when it is implement this one, then this class is our iterable class. And when they implement this one and the next, so then that will be the iterator. So that our my list is not our iterator, but is iterable object. So that is the concept we need to understand. And then you see here, my list is iterable, but it's not like a list or the dictionary. It's not the iterator. So we need to convert that to iterator. What's that do? It's just need to make our next magic the method. So let's copy this. So we put this iterator sample. So let's see. So first one is not iterable. Also, we need to import iterator. So that's 2. And the class my list the same. And define this one initial. So we need have a self list with a list. And also we need to give our index. That means it's needed as our iterator. So index equal to 0. And then the iter is here. It's not only in the past, we need to return myself. And then we define our return, turn, and we define next. Without next, your class will not be the iterator. So next is self. So we will put some logic here. So if self dot index, we have our index already, no more than length of self dot list. Then data equal to self dot list self dot underscore index. So that means we get the values through the index value, and then we need to increase self increase 1 to the index. So self index equal to self index plus 1. So that is the plus equal 1. Well, we can use this as the short. Then what we need to return is return the data. So here self is we define this data, and then we have another branch is else. What's else is raise stop iteration. So what this means, the condition is this self underscore index will more than or equal to length. Remember, if the length is 6, your index will from 0 to 5. So if index is equal to 6, that already overflow. So equal is also need to be prevented. So equal or greater than will trigger else. Then we will stop our iteration. And then we have our add data method. So not in. So this one is still same. Self append data same. And we have our string. These are same. And then we have my list, add Python, and add one is also need to be the ignored. Add file of files and Python, and then we can see. Let's run this first. So it's the same as previous, but what's the difference is for I, we can try to traverse. For I in my list, I wonder is whether I can use iterator so as checking. So iterator. So let's comment this first. Oh yeah, second is true. And if I put here, so let's just are testing. So I also load iterator. And I put here to check that. I suppose we should get false. So you can hear this is actually not iterator. This one is already our this one is our true. So iterator. So now we can traverse this print current traverse value is I. So this one is we already tested. Then let's see here. Current traverse is Python, and then go to the next is of size. So like if I have another, let's see, we have our hello. Then it can also traverse from this one one by one. So that is the iterator because it's implemented by the magic method. So we also mentioned this within this chapter. Remember, if you want our iterable object also our iterator, you need to implement both iter magic method and also next magic method. Then after that, you can traverse this because it's our instance like our iterator. So that is this chapter. And the next chapter we will come to this the inheritance and also the polymorphism. I will not need go to this too more detail because whenever you learn any other object-oriented the language, then you have these two together with the first one is the packing. So packing means you put kind of the data and method properties into one class. So we learned the class already in the past 3 subchapter. Next, we will learn another 2 characters of the object of the oriented programming language. But these two, depending on your the real coding, you will try to see how you will use this well. Thank you for watching. Talk later.